Dr. Lewis' specialties include brain tumor resection, awake surgery for brain tumor resection, frameless sorry if I can't say this right, stereotactic brain biopsy procedures, gamma knife radiosurgery, cyberknife radiosurgery, and including invention and development of medical devices.
Thank you very much. I'm more than privileged to be here with you and having this opportunity to present. So thank you for having me.
We're happy to have you here. Yeah.
So just tell me when. More than willing to give the talk, but just tell me when we're ready.
Whenever you're ready. Yeah, I see your presentation's up.
Perfect. So first of all, like I said, thank you very much, and we truly feel honored to have the opportunity and privilege to present here at the Precision Medical Devices Conference. So today we're going to talk about the butterfly effect, and you're going to see why. But first things first. Now, as you said, I'm a neurosurgeon by training, but everything started with me being a surgical intern that was by default left-handed, which was a blessing because that meant that I was faced with the task of learning how to suture, and because all the instruments were designed for right-handed surgeons, I was forced to analyze all the movements that I had to do because I had to adapt my hand movements to right-handed instruments, being a left-handed surgeon. And that was great. And that was what you would call a desirable challenge, because what that led me to do was that it led me to analyze all the aspects of suturing to see all the steps involved. And I realized that beyond trying to do something to improve ergonomics for left-handed surgeons and right-handed surgeons, there was something to do about all the steps involved in the suturing process. And I remember this came to like a climax when I had some ideas on how to try to evolve the needle driver, the basic instrument that we had, to see if we could make instruments that had a more continuous motion. And I tried to see what designs could I get that could allow me to do that. But I was stumped, didn't find anything that was simple enough to do that. And one day, I was post-call after being, in my neurosurgery residency, and I got invited to eat sushi. And you must be wondering, what the heck does sushi have to do with anything with medical devices? And this is where all of these big things come in. When I was in the restaurant eating sushi, I was so hungry being post-call that I ate every little grain of rice in that plate. And I ended up eating the last grain of rice. And this is where it all happened. I had the chance of having chopsticks that were round in cross-section. And I could pick up the last grain of rice with great precision and with a lot of pressure at the tip. And when I looked at the chopsticks to eat the grain of rice, I saw that they were round. And what they immediately gave me the impression of being was rollers. And it immediately hit me. Here I was trying to figure out how can I get a better design for something that has been basically the same for 150 years to try to maximize the mechanics of suturing. And then I have it. It's a pair of chopsticks. And it's like an eureka moment. So I went immediately to my apartment and I started designing. And, the result of that is, next slide, please, is what you see here. Okay. And for us, and for me, this was a great moment because it meant that I could really contribute something to the surgical field. But as a company and as we grew, this evolved into a corporate effort. I have been blessed to have a lot of very passionate colleagues that work with me, and we all work together towards this beautiful goal of getting this device developed. And we realized that one of the biggest pains in suturing was the fact that suturing in laparoscopic or minimal invasive settings was difficult. Next slide, please. And if you look, 56% of all the entering fellows, when they're doing their fellowship training in MIS, find it difficult or feel that they don't feel that comfortable suturing. But there is a lingering problem with surgeons even after they're trained because they see needle handling as a problem. And we did a market survey and we realized that surgeons were not satisfied with the suturing options that they had in their hand. They wanted things that had better needle handling. They wanted things that were more ergonomic, that improve hand movements. It made it easier to suture and shorter times for learning how to suture, because the technologies that are there were not optimal for them. And this is how we realized that definitely we were hitting on a note there that we could improve upon and contribute in terms of suturing technology available. Next slide, please. Okay. And the result was this. Okay, you can click again. So this is the drive and roll. And what you see is a device that is built on top of the architecture of a normal needle driver. And we have substituted the flat tips for rollers. And we have just created this dynamic relationship that changes, so you can slide that needle back and forth. And you can do that by just pressing a trigger, and that actuates the rollers, and you can move it back and forth. And the one thing that you can do when you can do that is that you can use it like a normal needle driver. So that means that it can open and close like a normal needle driver, and you can use it because of the versatility of the design in multiple angles. This is something that can definitely be reverted, so you can use the switch to revert from one place to the other, and it's a modular design. So it's ambidextrous, and it can be used for open surgery, laparoscopic surgery, or bariatric surgery, depending on the shafting that you use, because it's modular. So you have the reposable shafts that are like 5 uses, but then you have a reusable handle that you can use like 200 times. Okay, next slide, please. So the one thing that we know is that we have, because of our market survey and because of what we have learned, there are a lot of indications that we already know that could be benefited by the use of this device. And these include different procedures in laparoscopic surgery, like procedures for general surgery, like hernia repair, and also procedures for urologists, like let's say pyeloplasties or ureteral vesicle anastomosis, and procedures for gynecology, and that means hysterectomy, sacrocolpopexis, and myomectomies as well. Because at first we already know that this can be good for hard-to-reach places, but we also know that as the surgeons begin to use it, they will start seeing other advantages that this has for other procedures as well. So we understand that. Next slide, please. So first things first, our device can be used as a traditional needle driver. What that means is that you can capitalize on what you see, and even the Da Vinci, you see a simulation right here, has flat tips. You still have to drive it. You still have to torque your wrist. Okay, and if you want to do that with our device, you can, because we're not sacrificing any of the muscle memory and the training that you already have as a surgeon. Okay, if you see and you click again, you're going to see the video, and this is a cadaver lab in which we use the device and to simulate a bowel anastomosis. And you see how you can just grab the needle and hook the tissue as the surgeon does it, and torque your wrist as the surgeon just did, and use it just the same. So this doesn't mean that you have to sacrifice anything that you have already done. Actually, you are capitalizing on what you've learned. However, okay, go to the next slide, please. One thing that for us is very important is that this device is very versatile. And here you see a simulation of our rollers put at the end of end effectors, robotic end effectors, and you see this flowing continuous motion of the needle going through, which means that you can roll it through without ever having to torque your wrist, or without ever having to arc your upper extremity, your forearm, or your hand to try to accommodate that needle in any kind of specific angle. And if you look to your right at the video and click again, you're going to see the demonstration of that in the cadaver lab clip. Click again, please. That you're going to see right there. Okay, and look very well at the tip of that needle and how it retracts, and you can oppose it against the tissue and just pull the trigger, and it will just go right through it. No need to torque your wrist at all. Okay, now next slide, please. So when you put it all together, one of the things that you will see is that we have two instruments, two devices in one, built on top of a traditional needle driver, which means that there's all of the familiarity and simplicity of a regular traditional needle driver, and the advanced suturing characteristics and capabilities of a device that right now can be used as a roller as well. So it can do both things at the same time. Okay, and this is what you see right here. Next slide, please. Okay, please click again, and this is just to put it all in perspective. Click again, please. Go back one. Yes, you can click on the videos to click the to enable the videos. If you could. Yes. Hit play right there. One of the things that you're going to see there, and the video is actually going to show that, is that all of this ends up adding up to better suture handling. And as soon as the video plays, you're going to see. Okay, so one of the things that you're going to see right there is that as this video progresses, okay, you're going to see that our device, what it does is that starts suturing much faster because the flowing motion of every step allows it to contract each suturing cycle and each movement that handles the needle. And it is something that we could demonstrate right here. And after a while, our device just stops the suturing process because it completes it much faster than the other one. And then you only see the lagging behind of the traditional needle driver while doing that. You can click once again, and if not, we'll just keep on going with the next slide, please, if that's okay. No, but okay. Okay. Next slide, please. Our device is modular. Okay. And what that means is that there is a lot of versatility built into this device because you are allowed to use this device for all types of surgeries, meaning open surgery, laparoscopic surgery, bariatric surgery, and even robotic surgery. Okay. Why? Because this modular design is allowed to use not only the same technology, but the same device for these procedures. And there's flexibility also involved in the design because we can use it with an 8mm shaft diameter, and we can use it with a 5mm shaft diameter as well. So when you need a more rugged device, you use the 8mm, and when you need a finer device, you use the 5mm as well. Okay, so next slide, please. Okay, and as we have said before, we have this design that has a lot of versatility because it can be used with a mechanical handle as well as with a battery-operated handle. The handles are reusable. The shafts are reposable, 5 uses each. This can be adapted to a robotic end effector. Click again, please. And that means that you can use one single technology for all of your suturing needs in a hospital, which translates to a lot of benefits, not only for the surgeon, but also for the hospital as well, for the institution. Now, one thing that we realized when we were developing the device is that we optimized the way that the device worked. But we realized that the needles were not optimized to be used by this device because the needles haven't changed in 150 years either. So the needles that exist did not have the optimal function to that. And because of that, we tasked ourselves with developing something that ended up being something new and something that you're going to see right now, which are our proprietary X needles. Next slide, please. These needles combine the best attributes of J-shaped needles and half-curved needles and can be used not only for the driver and roll, but can be used with regular needle drivers as well. And why would you use it with a regular needle driver? Well, because the features of this needle, which include a flexible extension, mean that you could use this flexible extension for easier loading through a laparoscopic port, first of all, but it will spring back into its original straight shape and be grasped easier. Also, that extension has rigidity, but has also flexibility, so it can be used to loop the suture around when you're doing complex suturing techniques inside the abdomen when you're doing laparoscopic surgery. And this is something that saves time because when you don't have to have the needle in a specific orientation, like the smiley face orientation, what surgeons say, when they're trying to put the needle in any kind of specific position, which is another advantage of the driver and roll. You don't have to put the needle in any kind of specific position. You can just put it in the position that you want and then roll it back and forth. And the other thing that it has a tapered tip at the back that allows you to backtrack the needle if at any point you understand that the stitch that you threw was not the stitch that you wanted and you need to retract that needle. Sometimes if you don't have this, you have to cut the needle and start all over again or traumatize the tissue by pulling the needle back. And with this, this doesn't happen. So this is something that these are features of this device. Next, please. Okay, and on the left, click play, please. You're going to see that this can be adapted to the end effector of robots. And once again, the features of the device allow this to create a continuous motion. Can you hit play on the video clips, please? Look at how that flowing motion allows that needle to go through with much less needle handling, much less motion of those end effectors, okay? And you don't have to release, regrasp, and exchange instruments from one instrument to another. This actually uses two needle drivers, two driver rolls. And what it does is that creates this technique in which you can have the needle just go seamlessly through, flow from one needle driver, go through the tissue and be picked up by the other needle driver, and then just exchange the position and repeat the same process all over again. So it goes from needle driver to needle driver, creating this ease of motion and this ease of suturing to decrease the steps. And you need only to see the rate at which the two videos move to see all the different motions that you have to coordinate on the right side versus the flowing motions that you see that are much smoother on the left side. Okay, next slide, please. Okay, you can click again. So in the end, what we have created is a great technology that combines the simplicity of our traditional needle driver with the advanced capabilities of an advanced suturing device. And this is something that can be adapted to all scenarios in minimally invasive surgery and adapted to the needs of all institutions. And we're proud to say in Ergosuture that we have a team that has worked very hard to create something very good for surgeons, because we're surgeons designing for surgeons. So this is this is a device that is designed by surgeons for surgeons. Thank you very much for your attention, and have a great afternoon.
Wonderful. Thank you so much, Dr. Luis, for your insightful presentation. And it's remarkable what you guys are doing to transform the technology that everyday surgeons use, making their lives easier with the speed and, as you mentioned, the agility and precision, most importantly, of your device. And yeah, Steve and the audience, if you have any remarks or questions, feel free.
Yes, please. More than glad. Any questions?
Let me just look around here. Oh, there's one question from Miss Courtney Backstrom. She's asking, how does this differ from the endo stitch?
Very much. What it differs because it can use regular needles, and it uses half curved needle. It uses curved needles, which are the standard needles that you would use for traditional, in a traditional needle driver way. The endo stitch has a T-shaped needle that has the suture thread in the middle, and it alternates between jaws. This is not like that. This uses a half circle needle as you would use, and actually you can use our device with regular suture needles if you would want to, which also creates a lot of flexibility because the surgeons can use the needles and sutures that they have been used to using, and there are no special techniques to be learned or different training to be learned when using this device. With the endo stitch, you have to learn to use a different architecture for a suturing device. So it's in terms of functioning, it's quite different.
And if I'm not mistaken, I think the endo stitch is the one I think produced by Boston Scientific or Medtronic. I forgot.
The endo stitch was produced by Covidien, which was acquired by Medtronic. So yes, it's provided by Medtronic. Yes.
Okay, interesting. That's very interesting. Yeah. Any other comments or questions for Dr. Luis? Give like another minute or so. And again, this talk is being recorded, and for those that want to share this presentation with your teams, we'll have this available as well too. Yeah. Steve, any remarks?
So does this device actually reduce scarring in comparison to the traditional devices, or is it kind of hard to determine?
Well, no. At this point, we're not claiming that it will reduce scarring. What we know is that this device can allow you to have greater consistency in the way that you throw the stitches, because the device drives the needle on its own arc. So it's not an unpredictable turn of the wrist in terms of where is it gonna fall, but rather when you put the device there and you just hit the trigger and the rollers actuate, the rollers get a very regular movement through that is just determined by the arc of the needle. So it's very predictable. And that might mean more consistency of suturing, but I would not go as far as to say that it will decrease scarring, because this is not the purpose for the device. It's just to enhance the suturing process to make it way more efficient with less needle handling.
No, yeah, that's great to distinguish, and you should be very proud. Your team looks like you all have done a great job. Just the presentation in and of itself, I'm always very impressed by devices like these in the medical field.
We have a great team. We have a great team. We're very proud. I have to say I'm extremely proud to be part of a very dynamic, passionate, amazing team of people that really have outdone themselves in every way to get this forward. So it's a big family, and we're very proud of being very passionate about giving our best to the surgical field and to the patients.
Yeah, I'm just reading some of the comments people are making on the chat, and it's just a very impressive mechanical device. I mean, just speaking from perspective of an engineer, it's very impressive.
Well, thank you very much. We will humbly accept that. We are very proud of what we're doing.
Yeah, there's one more comment from Courtney. She's asking, is there any data that proves this will minimize OR time and produce faster throws?
There are actually, we are working on such data. The video that did not play well did show some reduction in suturing time, which was about 20%. But of course, we are very responsible in the sense of providing hard data for that, and we're going through that this moment.
Wonderful. And you can always connect with him and his other team members, as you mentioned. You can connect with them on LinkedIn. You can follow their company page. They post regularly with updates and what they're doing. So give them a follow on LinkedIn and Twitter if you haven't already. So again, thank you so much, Dr.
No, thank you. My pleasure.